Study of optical and electrical properties of NiO nanostructure thin film. Nickel oxide, NiO, thin films were prepared using a simple spray pyrolysis technique from hydrated nickel chloride salt. Solution, nickel 2.6H2O, deposited on glass substrates at temperature, 450 C degree, and with different solution concentrations, 0.4-0.6-0.8-1 m. Structural and morphological properties of the grown NiO films were studied using X-ray diffraction, XRD, and atomic force microscope. NiO films with nano-grain size were obtained. The value of nanoparticle size ranged from 24.68 nm to 34.08 nm. Transmittance spectra recorded using the spectrophotometer in the range of 330-2200 nm. The absorption coefficient and the optical band gap energy were calculated. The band gap of NiO film decreases from 3.7 to 3.2 eV as the molarity increased from 0.6 to 0.1 m. Both the electrical resistivity and the activation energy of the prepared films were calculated. Nickel oxide thin films are very important to be used in many scientific and technological applications. They have achieved great success when they were deposited on glass substrates in various physical and chemical ways. The most important ways are thermal spray, pulsed laser, chemical bath deposition. 16. Nickel oxide films have some electrical and optical properties such as band gap in the range of 3.1 eV to 4 eV and electrical resistivity is in the range of 10 to 1060 cm. 15,12. Nickel oxide, NiO, material has structure like NaCl type with lattice parameter 4.177A4. It offers promising candidature for many applications such as solar thermal absorber catalyst for O2 evolution, photoelectrolysis, and electrochromic device. Nickel oxide is also a well-studied material as the positive electrode in batteries. 3. In this paper we prepared thin films by the spray pyrolysis, SP, process owing to its several advantages such as low cost of the apparatus, large area with high homogeneity and easy control of structure of the deposited films. 5. 2. Experimental. Nickel oxide thin films were deposited from aqueous solution of nickel 2.6H2O by SPT on glass substrates. Precursor solution was nickel 2.6H2O of concentration 0.6 m, 0.8 m and 1 m. This was mixed and stirred in 50 ml distilled water for 10 minutes. The substrates have been chemically cleaned by standard methods. Nickel chloride solution was sprayed onto the preheated glass substrates, which undergoes evaporation, solute precipitation, and pyrolytic decomposition, thereby resulting in nickel oxide thin films according to the following reaction. 13. Plus. The thickness of NiO thin films was measured using weight method, which depends on the difference between weight of substrate before and after deposition of the films. The thickness can be calculated from the relation below. The XRD spectrum showed that at a molar concentration of 0.4 the film did not crystallize, and with increasing of precursor concentration from 0.6 to 1 m the commencement of crystallization was observed. It is seen from XRD patterns that 3 peak appears were given in table 1, which is attributed to the 111, 200, 220 diffraction peaks and clearly indicated that the NiO phase exists under its face-centered cubic FCC structure, which is in good agreement with Joint Committee on Powder Diffraction Standards, JCPDS card number 04-0836.8,12. Conclusion. The XRD results reveal that nickel oxide films with nano-grain size were obtained with different molar concentrations and were found to be polycrystalline. The XRD data show the dominating peak is 111, and the nickel oxide films have cubic structure. The AFM results reveal that the surface of films is highly smooth. The transmittance value NiO film decreases from 80% to 61% as precursor solution concentration increases from 0.6 m to 1 m. The optical energy gap of NiO with concentration 0.6, 0.8, 1 m were equal to 3.7, 3.5 and 3.2 eV. The activation energy for NiO samples of different molar concentrations were equal 0.317, 0.318, 0.30 eV respectively, and electrical resistivity decreases with increasing in temperature.